Hi everyone. Today we'll talk about singleton class in Java. As you know, it's a very important concept. Please go through this session and I'm sure you will be very clear about this singleton class. Why we need this and what is the singleton class and how to create it. So all these things I will explain. So please go through this session and we'll see. Okay. So singleton class means a class if we can create only one object throughout the application, then that class called as singleton class. And why we need that kind of class? So some scenarios we want only one object, so we will not create multiple objects, such as suppose we want DB connection only once throughout the applications and we'll make use of it. We will not create multiple DB connection object, so it will be we are going to lose memory. Suppose we are doing logging, so we'll create only one logger object. So like this we are having multiple use cases. So singleton class. So let's create one singleton class example for more clarity on this. Okay, I will create a demo class. So I am going to write a class, singleton class. Okay, so if you write a class and you wanted to make that class will be singleton, only one object will be created, not multiple objects. So three things keep in mind. So we need to define the constructor as private, so that outside no one can create the object. First point. Second point, you will have a method which is returning of this class object. So that method will define as public and static, so that without creating the object, if anyone wanted the class object of this class, so he will call that method and he will get that object. And third thing is we will have a static variable and we will make as private, so that no one can modify it, in it will not innate. Okay, so we'll make as private, and that instance variable, one variable will define, that variable will initialize this object. Okay, so that it will return that method. So no need to worry. What I will do, I will define a private constructor. Okay, let's define that. So now you will define a method, public, static, and that method of this class type. That method name, any name you can give. Get instance I am giving. Okay, and you will return a object here, right? This method will return the object of same class, right? Let return it instance. And this instance I will define here private, static, type is single, so I will return this object. So I will create this object. So only one object I wanted to create. So I will check if this instance equal to null, then you create the object. First time you will create the object, and second time onwards this condition will not be true, right? And that object you initialize here. That's it. So let's call that get instance method. How to call that get instance method? It's a static method. You will use by the class name dot single dot get instance. So let's print it, and we'll call multiple times. We'll check whether it is one object is creating and same object it is returning, or it is creating a different object. How we can answer? How we can answer that same object is creating? You see the hash code of this, it is same. So first time we call, right? So it take check this, it is null, so it is created a new object. Second time onwards, same object, this condition is not satisfied, right? So it is same object, it is written. So this way we can create singleton object. Okay, it's simple. So three things only. We'll have this method, we'll have this private constructor, so that here outside I cannot create like new singleton, I cannot create a new object. Because I cannot do so. I cannot do single s equal to new single because it is not visible. We have defined as private. That's the reason we cannot do that. Okay, but still we can break this. Means some scenarios is there, so it will be break and it will create multiple object. What is that scenario? So if you are working in a multi-threaded environment and multiple thread wanted to create object of the singleton class, so they will get different multiple object. How? Suppose T1 T2 both the thread it checked, and here in line number 13 both the thread, for both the thread at once it at a time it checked. So for both the thread it is null, right? So it will be created two different object. So how to prevent it? So here what we will do, we'll define this class as synchronize. Sorry, this method will define as synchronize. Okay, so that multiple means we can prevent this. But don't you think this is a performance issue? If whole method will be defined as synchronize, multiple thread is working at once. Thread 1 came and it came inside, right? It logged this whole method, and while T1 other thread T2 T4 T5 all other thread is waiting, right? And even though T1 entered and created a instance, okay, and T2 still it will enter this synchronize method and it will check. So that at the same times other thread also waiting, so each thread it will be enter this block, it will enter this method, so it will be costly, it will be performance issue. So our problem is this line number 14. So this is the critical section. So why will whole method will define as synchronize, why will block the whole method? So instead of that, what you will do, will define that this line alone will define a block, synchronize block. This is the critical section. So this is the syntax actually, single dot class. Okay, so instead of defining the whole method as synchronize, we define this block as synchronize. You see, but this is not the actual solution. Here also it will break. Let's say T1 T2 multi-threaded environment, both the thread came line number 13, and for both T1 T2 both are true, means it is an object is not created. T1 is entered inside this synchronized block critical section, T2 is waiting still. T1 is created a object, and once it is released, it is about to return, but this T2 also is waiting, right? Once T1 is released, T2 entered this critical section and created a new object. First T1 is entered and created a new object, while T2 is waiting here, because both T1 and T2 checked first in line number 13, both are true. So T1 entered and it is come out, and T2 also will be entered in the synchronized block, and it will create a new object. So how to prevent it? We'll do one more check here. If we'll do one more check here, if we'll do one more check here, so this is called double check singleton logic actually. So both, let's say T1 T2 T3 T4 multiple thread is coming, and two thread at once they checked both T1 and T2, both the them, for both them it is true. So T1 entered, T2 wait here, T1 entered and it checked it is null and created a object. Okay, and while T2 came and it checked it. So that time already T1 created, right? So T2 here will check, it will be false and it will return the same object. So if we will do this double check, so it will be the solutions actually. So before double checking we are able to create, we are breaking the rule. So now also there is a chances of breaking our singleton logic, because we have not defined here volatile. What is this volatile? Sorry, here we need to define. Now it is purely singleton. Okay, so what is this volatile? Actually this thread is working in two memory. It is main memory and cache memory. Each thread having his own cache, one own stack area. It is working in his CPU. Okay, so T1 is created the object, but it did not write to the main memory. It kept that object, it is in cache memory, whereas for T2 is checking in the main memory. So that's why even though T1 is created an object, for T2 it is not visible. That's why it is breaking. But if we define as volatile, will be make sure that we will not use that cache memory of the CPU cache memory of the thread. We will read always from the main memory, and main memory, whenever it will write, right, it will, before reading, it will check is there any write happen or not. First it will do write, then read. Don't be confused. I will explain what is this volatile keyword. Okay, you see, so threads are working in CPU, and each CPU having cache memory, T1 T2 both the thread. Okay, so whenever, why they are using this CPU and own cache memory, because reading a variable or reading from main memory, it will take 100 nanosecond around, but if they will read from cache, it will take 7 nanoseconds, so around 10 to 12 times more. So for faster processing, each thread having their own stack and own CPU, own cache memory. So if suppose there is a shared variable, okay, here our instance variable we can say. Okay, so that variable, it is not visible to T1 and T2. So suppose this variable first time read, and then it kept in the cache memory. First time it is accessed and kept in the cache memory. So whenever T2 is reading, it is reading in his own cache, it is not reading from here. That's what you see, if T2 is updated something, so for T1 it is not visible, but because T1 is already, T1 always is referring to his cache. If T2 is updated this shared variable, it will be updated in cache. It will take time to update here. So the immediately it will not get this value. That means T2 is updated that value, it will be sync here. It will take some times, and still T1 is referring to his cache. So thread 1 does not immediately see the update value. Okay, whenever reading, he is writing, but he is not getting, T2 is updated that value, but thread 1 is not getting that. So if we make this variable as volatile, it will be make sure that both the variable read and write, both are reading from this memory, main memory, not using this cache memory. So if thread 2 is writing, it will write to the main memory, and thread 1 it will read the same. If both read write is happening, this volatile keyword is that capability having, it will wait until any write operation will be done fast, then it will be read operation. So that's why it will be make sure that all the instance, all the variable, it will be accessed from the main memory. It will not use the own cache memory. but what we are losing, we are losing the performance, but consistency will be there. So whenever really we need, that time we will use this volatile. So that's what in our singleton logic, this variable, it is, if will not define as volatile, if t1 is, it is updated, created a object, and it is trying to access, kept in the cache memory and trying to access in cache memory. Whenever t2 is trying to access it, it will searching in the main memory, so he is not getting that. That's right, both t1 and t2, it will create different object. So like this we can prevent, this is known as double check singleton pattern, singleton logic. So like this we can have multiple ways like enums and all, we can prevent more ways also will be there to create the singleton logic, but this is one of the best way. Before this volatile keyword actually introduced in java 5, before java 5 we are not able to handle this safety, so it can break, we cannot save the singleton. So this is the way actually. So only three things you need to remember, like you need to understand that we'll have a method which should be public and static, so that will return the same, it will return the object of the same class, and we are defining the constructor as private, so that outside no one can create the object of it. And we'll define a instance variable here, we can define a variable here, class variable, the name instance variable name, anything you can give the variable, so that we'll initialize that and will return it, and that can be private and static. That three things you will keep in mind whenever you are creating a singleton object. So I will explain more about this enums and other ways how to create it in a separate session. So this is all about the session. If any doubt, please let me know in the comment section, I will respond. Thanks for watching this video.